Hello everyone. Today we shall talk about transportation of soils. Before that, in the last lecture, we have talked about how the soil formation takes place. As you know, there are two methods by which soil formation takes place. The first one is the physical disintegration and second is the chemical decomposition. So once soil formation takes place at any locations, right? Then the next points come transportation of soil. So we shall talk about the transportation of soils today. So what is going to happen? What are the agencies which transport the soil from the location of soil formation to the new locations? So various agencies are there. For example, ice, water, wind, and gravity. So the next point comes under the residual soil. So from the location of soil formations, right? What is going to happen? Some soils will remain there itself at the time of soil formation. Some soil will retain there itself. And some parts of the soil will start moving from that location to new locations. You can see the soil formed by the weathered products at their place of origin are called a residual soil. So whatever the soil is going to retain nearby the location where it has been formed is called as the residual soil. How we can identify it? That it is a residual soil? That we can identify by the gradation of particle size. We can see in the residual soil, the fine grain soil is found at the surface and the grain size increases with the depth, right? Fine grain means the less than 75 micron size particles will be available at the top surface, right? And as depth increases, the size of the particle will also increase, right? So normally, the depth of residual soil varies from 6 to 25 millimeter. The next is the transported soil. You see that the soil formed from soil formation has taken place at any location, right? By the methods of physical disintegration or chemical decomposition, right? So in that case, what is going to happen? It is going to be transported by different agencies from original location to the new locations by one or more of the transportation agencies. What should be the agencies? For example, water, glacier, wind, and gravity. Now we shall see water transported soil. Soil may be transported. What I'm trying to say here, once soil along with the water moves from the original location to the other location, normally what happens? Some particles will be rolling at the bottom of the stream. Some particles will be sliding. So this and some particles will remain in suspension in the soil, in the water. So particles transported by water range in boulder to clay. Normally, water carries the clay to boulder. Boulder is the bigger size, right? And clay, as you know, the clay is the less than 2 micron size. Particles are called as clay size particles as per the IS classification. So, and coarser particles are dropped when a decrease in water velocity occurs as the stream or river deepens widens or changes directions. Coarse particles, that the heavier particles, will settle. Where it will settle? When the water velocity is going to decrease, or when water velocity is going to decrease, when the decrease in velocity of water will occur, at what will, how it is going to happen? See, a stream or river depends when the water which carries the soil, and as we have seen that the boulder to clay, the coarser particles will settle down when the river is deepen, right? Deepen means where the depth is more, or where the along the way, because water is carrying this soil. So what is going to happen? Wherever the river is widened, the width is more, or when the river water is going to change the directions. In that case, the coarser particle will settle, and fine particles will remain in suspension and get deposited in quicker waters downstream. That means when the velocity is going to be completely decreased, right? Or suppose the water becomes completely quiet. In that case, the fine particles will start settling at that location. Soils that are carried and deposited by rivers are called alluvial deposits. So this we have to remember. This we have to remember, that whatever the soil going to be carried by water, right, from the original location to the other locations. So along the way, definitely settlement is going to take place, and the soil particles are going to be accumulated on the earth, right? So it is called as alluvial deposits. Alluvial deposits, right? It is the soil carried out by the river water. Soil particles carried by rivers while entering a lake deposit all the coarse particles because of sudden decrease in the velocity. What does it mean? Along the river, as you know that the river is carrying the soil particles, which varies from clay to boulder, right? So along the way, whenever it is going to enter in the lake, what is going to happen? At the time of entering into the lake, the velocity will decrease. So in that case, the coarse particles will settle at the at the entry point itself, right? So that deposits are called as lake deltas. But the fine grains particles move to the center of the lake, settle when the water becomes quiet. Alternate layers are formed with season, and such lake deposits are called lacustrine deposits. That means, as I told you, that the coarse particles will settle at the entry point of the lake, and inside the lake, when the velocity of water is going to become zero, also we can say. So in that case, whatever the suspended particles are there, that will settle in the lake. And depending upon the seasons, the layer-wise settlement will take place, right? And that deposit in the lake is called as lacustrine deposits. See, the next point is the glacial deposited soil. Glaciers, see, three words are there: glaciers, ice, and the snow. Okay, so depending upon the climate of the location, what happens? The soil particles, or we can say wherever the soil formation has taken place, right? And that location, suppose it exists in the cold region. So even the soil is going to become in the form of a ice. And at the same time, if the snow is going to fall, right? The compaction will also take place. So this process will continue. The snowfall will also going to continue, right? And the soil is also going to form a ice, right? Because of the decrease in temperature. So ultimately, it will be it will become a glaciers, right? The size of the size of the soil, which is going to become the ice, right? Ultimately, it is the glacier. It will be big size. We can say it will be very big size. So in that case, what is going to happen? The glaciers grows and move. As it will become big size, definitely it will fall down and start moving, right? And carry with them the soils varying size, because already the soil has become ice in the cold countries, and the snow has also fallen in that area. So if the snow is coming from top to bottom, right, definitely the compaction is also going to take place, and it is going to become the glaciers. So the bigger the glaciers is, the grow means is the size of the glacier is going to become big, and it will start moving, and definitely it is going to carry the soil along with the ice from the fine grain to huge boulders. From the fine grains, that means along with the ice, the fine grain soil will also be there. Clay will also be there in the glaciers. Boulder will also be there in the glacier. So once it will start moving, what is going to happen? And suppose it is moving, and it is also going to melt along the way. So in that case, the soil will deposit on the surface, and water will go in the forward direction. Soil get mixed with the ice, transported far away from their original position. You can see this figure, how the glaciers are moving, and ultimately, as the melting takes place, right, the soil is settled in that area, and water will go at a different location. It will move at longer distance. Deposits directly made by melting of glacier are called till. So whatever the deposits are going to take place due to the melting of glacier is called as till. It is denoted by till. So what is said that deposits of glacial till are generally well graded and can be compacted to a high dry density. That's why it will have high shear strength. We can say the bearing capacity of this soil will be high. Now we shall see the next point: wind transported soil. Wind is also a major transporting agent. Wind also carries soil in the form of a dust, right, from one location to the other location. When large areas of sand lie exposed, wind can blow it away and redeposit it. Wherever the sandy area is exposed to the atmosphere and wind is blowing, definitely it will carry the sand particles along with the wind, right? And a dust storm, that is called as dust storms. Normally we used to see in the summer season also. So dust storm gives a visual evidence of the soil particles carried by the wind. You can also see that when in the summer season wind is blowing, it is also carrying the dust along with it, right? So as the wind blows, as it travels a longer distance, the speed of the wind is going to decrease, and whatever the particles is going to be carried by the wind will also settle down on the ground surface. So deposits of wind-blown sand take the shape of a dune. You can say this type of shape is called as dune. A dunes are formed. The sand is blown over the crest by the wind. So this is called a crest. Okay, and the particles are, the sand is blowing through the crest. So it is going to form a shape like this way. Okay, and these are the wind which carries the sand particles. So because of the wind pressure, this area is going to be compacted, and this side no compaction is there. Only the particles by rolling, it is falling down and getting deposited in this side, right? This process tend to form a compact sand deposit on the windward side. See, this is called as windward side because wind is coming from this side. This is called as windward side, and this side is called as leeward side. So what we can say, the soil deposited by wind are known as aeolian deposits. So this type of deposits, or we can say, whatever the soil is going to be transported from the place of soil formation to the other location, right? That deposit is called as aeolian deposit. Once again, the dust which is going to be carried out by the wind, definitely it is going to be deposited at some locations. That deposit by the wind is called as aeolian deposit. We can see the next point, gravity deposited soil. Gravity can transport materials only for a short distance. As you know, as the wherever the formation of soil takes place, right? So some particles or some the soil, the bigger size or the smaller size, right? Once soil formation takes place, it will fall down due to gravity. Okay, the gravity deposited soil. So you can see from the top of the hills where the formation of the soil has taken place is going to fall right at the bottom of the hill. So this part, see this the fallen soil is the gravity deposit, which is termed as talus, TLUS. It is called as talus. Next deposit, we can say swamp. What do you mean by swamp and marsh deposited soil? This also we have to know. This question is also asked. So what it says that in water a stagnant area where the water table is fluctuating and vegetation growth is possible, swamp and marsh deposits develop. A stagnant means the water is not going to move from one location to other location. You can see this area, this part here, the water table is fluctuating. There's some and the grasses are also there, bushes are also there, vegetation growth is also there. So this the vegetations and the soil particles are going to develop some marshy land or the swampy land, right? This land will be considered as a swamp land where the vegetation growth is there, right? And the fluctuation of water table is also taking place. Water will also be there. So grasses will rotten there, and this type of deposit will be called as swamp and marsh deposits. Soil transported and deposited under the environment, right? Whatever the soil is going to be deposited will definitely be soft, high in organic content because the bushes are there, grasses are there, vegetations are there. That is the organic matters. So it will give the unpleasant odor. The bad smell will also generate. So some other definitions are also there. We have to know what do you mean by peat. Peat is partly decayed organic matter. Peat consists of decaying vegetable matter. When added to soil, enriches the better plant life. What does it mean? Suppose you are going to use the decayed plants, leaves, or the decayed vegetable matters. In that case, if it is going to be mixed with the soil, definitely the fertility of the soil will increase. And in that case, whenever you are going to plant the trees or plant the plant any whatever you are going for planting, definitely the growth of the plant will be good in that case. So wherever the peat is there. One topic is muck. What do you mean by muck? Muck is called as organic soil with very high moisture content. So wherever the organic soil is there, that means this soil which is having more organic content and with very moisture content is called as muck. The definition of the muck we can write like this way. Muck is fully decomposed materials, spongy and light in weight, highly compressible, not suitable for the construction purpose. See, on the ground surface, wherever the muck is there, on the muck, it will not be suitable to construct the foundation or any structure, because the strength of the muck will be very, very less or very poor. Why? It is a spongy, it is light in weight, or we can say it is highly compressible. It is going to be consolidated. That means the soil is very soft and not suitable for the construction purpose. So next is the loam, a mixture of soil grains of various sizes, such as sand, silt, and clay. Loamy soil. Which soil we can say as a loamy soil? The soil which consists of sand, silt, and clay, that soil we can say as a loamy soil. So thanks to all of you. So this is all about your today topic. Now we shall go for the next topic in the next lecture. So thank you very much.